Hello, everybody, and welcome to another episode of Clay Loves Logic, where on this channel I solve logic-based Sudoku puzzles I find interesting. And today I have solved a couple puzzles already, and I have had about 8 hours of sleep in the past 2 nights because I've been at a couple of busy concerts, and I've had a very crazy weekend. So with that in mind, let's try a tough puzzle. I'm sure that'll go good. The 1s and 2 stars I solved today were fine. Let's try a 3. Today, we're going to be doing the puzzle Stolen Numerals, XV times VI by NurglesGift. I've solved a couple NurglesGift puzzles before. They tend to be coloring puzzles, at least for me. This one looks interesting by the rules, and I don't know how well it's going to go or if you'll even see this, but if you do, the link to the puzzle is in the description. Give it a try. And if you do, definitely consider liking and subscribing, because if I manage to solve this puzzle today, I'll be pretty proud of myself, and this will definitely be a video. Let us get into the rules. Normal Sudoku rules apply. You have to have the digits 1 to 9 in every 3x3 box, in every row, and every column. Cells connected by an X sum to 10. Cells connected by a V sum to 5. The green the green dots are either X's or V's, and all X's and V's are given. So all of these are X's or V's. It's up to me to determine which they are, and they could be either, but they're all given. Cells connected by a black dot are in a 2-to-1 ratio, and cells separated by a white dot are consecutive. Well, first thing I'm going to tell you, this digit, this digit, this digit, these two digits, and this digit are all in some sort of property of summing to X or V, aren't they? And things that sum to 10 or 5 are never 5. So that's a 5. These digits. Okay, I mean, it is true to say that there'll be a 5 in one of those spots. 5 in one of these. Okay, maybe that's not fruitful, actually. There might be way too many things that could be 5 to start penciling like that. Maybe that is silly. Although this one, we do get another there. And then this one can't be. So actually, look at that. So none of these are 5s. That's not 5. That's not 5. So this is a 5. Okay, you know what? Maybe this isn't so bad. There's lots of things that aren't 5. Actually, 5 is always down here now. And then 5's always here. Okay, you know what? That's not so bad. And this central box, less interesting. 5 in one of 3 places. But is that all the 5s now? 1, 2, 3, no. 4, 5, 6, 7. I got to deal with the 5s in these middle boxes. Lots of 5s are going to get marked in. Okay, I'm not going to bother, I don't think, with the remaining 5s. Well, maybe briefly. Yeah, because already now one thing I can see is that this can't be a 5, nor can this, nor can this, nor can this, nor can this because of this 5. Right? I mean, anything with a green dot sums to 5 or sums to 10, so it can't be a 5. And 5 can't be in a 2-to-1 ratio. So these two can't be 5. That can't be 5. That's not 5. That's not 5. This is not 5 by Sudoku. So all of a sudden, 5 in this row is precisely here or here, which means there's no other 5s in this box. It's limited. This is not a 5. So this 5. So then all of a sudden, you know what? That's actually not so bad. Yeah, that's not so bad. Okay, let us think about this puzzle then. How do we want to go about this? How do we want to go about this? Because, I think this is the most interesting spot. So maybe let's start there. And let's just color. So let's say blue and pink have a relation that either sums to 5 or it sums to 10. So either way, this could be a 10, right? It could be, yeah, it could be a 10. But what I can tell you then is this digit here has to sum to something with the purple. And then the purple has to sum to something with the blue. But what does that mean? And what does it tell us? What does that mean? If this is 10, I'm just going to put some numbers in here for a second. Let's imagine that's a 10. This would then have to be a 5. This would then have to be a 10. So as soon as this is a 10, this would have to be a 5. Well, sorry, it would have to be a 10 here. And then this could be a 10 or a 5. Okay, what if it starts as a 5? What does that tell us? This is 2 and 3. This is the point where it switches, right? Because if this is a 10 pair or a 5 pair, this is the point that it then tips into the other thing, the other relation. And then this one would have to be, oh, that doesn't work, does it? Yeah, that doesn't work. That's really nice. That's really nice. Let's just think about this. So if this sums to 5, then these two sum to 10. But then these two have to sum to 5, and they can't sum to 5 because we have both the low digits here. So I'm going to change the coloring because when I do these puzzles, I like to do, darker colors for highs and lows. And again, I don't know if this is high or low yet, but I'm just going to say that this puzzle operates something like that, where now, this or well, actually, this is always the high digit, isn't it? Because if this was 2, this is 8. Well, 8 can only sum now to 10, and it can only get there with a low digit, and the low digit would be the other one. So that doesn't work actually. I hope that made sense. But what I'm saying is this is a high digit. This is 6, 7, 8, or 9. It just is. That's the only option. That's the only option. Because if these two digits sum to 5, then this digit sums to 10. Then this digit has to sum to 5, and it needs to use one of these two. So these two digits sum to 10. If this is the low digit and this is the high digit, you need to just put this low digit here again to sum to 5. So these two digits sum to 10. This one is the high digit. This is a 1, 2, 3, or 4. That makes this a 1, 2, 3, or 4, and it's its counterpart. And the second you have this relation, this digit therefore has to be the 6, 7, 8, 9 that sums to. So then this has to be blue because this has to be the low digit. And now this can be pink or dark blue. Because now this either sums to 5 or it sums to 10. All right, that is true. Oh man, this puzzle is going to break my brain, I'm sure. I'm sure there's just going to be so much logic like that. Well, this relation here, we need 4 cells that are doing something. Yeah, that's a way to think about it. These 4 cells need to then have the relation of 5 and 10, right? These 2 cells need to have a relation that impacts these 2 cells. So these 2 cells could never be 1, 2, 3, or 4. You can't start with a low digit here because you'd have 1, 2, 3, 4, 6, 7, 8, 9. That's fine. This sums to 10. But if this is the high digit, what do you do here? You can't do anything. These digits are high digits, and they're going to be my high digits I use in these coloring puzzles, which are going to be orange and tan. They're going to be from 6, 7, 8, and 9. This is going to be green, and this is going to be yellow. Green and yellow are both 1, 2, 3, 4. When I do coloring puzzles, these are the colors I pick. I don't know why. I just do. pink and purple sum to 10 because they're a similar color. You know, pink's the lighter one, purple's the dark one. Together they sum to 10. Light blue and blue sum to 10. I don't know why. That's how I do it. Yellow and green always sum to 5, and green and orange sums to 10. Yellow and tan sums to 10. I don't know why. Those are the colors I've picked. I've always been doing coloring puzzles that way. So now we have one last relation here, which is a 10 pair, and it simply just has to be purple and pink, because the only other 10 pair option is blue and light blue, but you know, we have dark blue in here. So the next question is, where's blue? Light blue's here. And it is 1, 2, 3, 4. So this is a 5. And now those are not 5, but this is a 5. That makes this a 5. This is not a 5 anymore. These aren't 5s. So this is a 5. These aren't 5s. Nice. Okay, so now we have to have a blue digit somewhere here. And I'm going to do the same thing I did before, which is, can this be blue? And it can't. It can. Sorry, it can. Because this can be blue, this can be pink. Oh, no, that doesn't work. That doesn't work. That doesn't work because of this digit. If this is blue, then this is dark blue, or it's pink, right? Because if this is light blue, then these two digits have to be the complementary digits that will either let us sum to 5 or 10, because blue's light. Or it's blue's small digit. It's 1, 2, 3, or 4. So if this is 1, 2, 3, or 4, if this is dark blue, the only complementary digit left is light blue, which it can't be because there's a light blue in the row. So the other option is this is pink, which is fine. That sums to 5. But then what do you put on the other side of pink? You can put light blue to sum to 5, or you can put purple to sum to 10. But we have a pink purple here, so we can't have both. So this digit cannot be that. This has to be light blue. It's only there. And now we're going to need, how does this then work? Well, this is going to have to be dark blue, isn't it? I hope you can see why. It can't be pink. Because if it's pink, the only other option is the dark blue goes here. But again, then what do you put beside it? You put light blue. But we already have a light blue in here. So the relation has to be pink into purple. And that relation means this is no longer pink and this is no longer purple. And pinks are our digits from 1, 2, 3, 4. Purples are our digits from 6, 7, 8, and 9. Well, now we need one more relation that sums to 10, and the only option is yellow and tan. Oh, this is a fun puzzle. I am really, really enjoying this puzzle. Okay, so we need a pink somewhere here. And again, doesn't that mean that pink is in the middle? Isn't that what we're learning? Because if it's not, because look, we need a pink in this row. That's absolutely true. If it's here, fine. Oh, no, it could be. Sorry, it could be. Pink could be here. It would have to be flanked with light blue and then dark blue. That would work. If pink's in the middle, we get blue on one side and purple on the other. Oh, well, there you go. Look at that. Look at that. We need a purple in here. We need a purple in here. So purple has to be on one of the ends. So pink is in the middle always, and then it's purple or it's light blue. Because basically it needs to be the 5 pair either here with a 10 here, or the 5 pair here with a 10 there. But either way, that's the only way it works. And of course we can see, you know, we have this roping. It's what it's called when you see these repeats of patterns, you know, in rows and columns. Okay, this is some really, really good puzzle. It shouldn't surprise me. I've done a number of NurglesGift puzzles, and they're always just so much fun. We need a dark blue somewhere in this column. It's going to be here or here. And again, the dark blue in this row might be interesting because it's not there or there, because for it to be in any of these spots, it would have to be beside light blue. The only relation dark blue can make is a 10 pair, and it can only get there with a light blue. So this or this could be dark blue. Could this one be dark blue? Let's think. If this is dark blue, this is light blue, this is pink. Ah, nope, not possible. Look, there's a pink here. If this is dark blue, it has to go to a light blue, which is fine. But then it could either go to dark blue, which it can't because it's in the same row, or it can go to pink, which it can't because it's in the same row, or same box, whatever. So we have two spots to put blue in this row. These pairs now. Well, this is not a blue pair, and it's not a pink pair, is it? Because we can't put, well, let's not get ahead of ourselves. That's not true. That's not true. Sorry, that's not true. This could be dark blue. This could be light blue. This could be pink. This could be dark blue. This could be, no, that wouldn't work. Sorry. But it does work where this could be dark blue. There is that is fine. This could operate like, this. Oh no, it couldn't. Look, there's a pink there. So that doesn't work because this can't be dark blue for the same reason. Let's think about that. This can't be dark blue because there's not two options for it. This can't be dark blue because it would require a pink somewhere. Yeah, okay, great. So this whole section is going to be one of these options. It's going to be from those. It's either going to be, green, orange. Well, another interesting point to note here is this central digit. This central digit. Can it be, it can't be high, can it? It can't be high. It can't be high. If it's a high digit, these have to repeat. So this is a low digit. So it is not rust or tan or orange or tan, whatever you want to call it. This is green or yellow. And it will be flanked by a green, yellow, or, well, a green, yellow, and then a tan orange. Okay. So these pairs now, what are they? Well, this pair is not, that's the next interesting point, isn't it? This pair here, this is not pink purple. Because pink purple's here, you couldn't put any of the digits pink or purple here, which means you can't put them there. This digit can't be pink purple, these can't be pink purple. And then technically, this one could be pink or purple. But where do you put the other one, right? This is not pink purple, nor is this. These two can't be because this one can't. This is a purple pink pair, and then it has to be in just this option. Yeah, that is true. That is true. That is true. So then this has to be of this variety. And then this will be whatever's left. This will be one of them. Okay, this is a relation here that's happening that is not a 5 pair, and it's not this 10 pair, and it's not this 10 pair. So it is going to be one of, it's either a 5 or 10 pair using these digits. I don't know which yet. This is going to be tricky to place. I think, I don't know yet. We'll see. Well, we need to put blue somewhere in this, light blue. Well, you know what I can say is we have 3 unique digits of the other side of the 5 and 10 world, right? The way I think about this puzzle is I think about this puzzle in terms of 5 and 10 pairs that are sharing relations. And so when you think about these XV pairs, blue and dark blue is an option that sums to 10, but its relational friend is pink and purple, right? They're intertwined because pink and blue sum to 5, pink and purple sum to 10, and blue and dark blue sum to 10. So pink, purple, blue, and dark blue share this relation of, well, yeah, they share this relation. So when I think about these XV puzzles that have these colors, I think of them as distinct sets of 4 digits that have to operate like that. So I hope that makes sense, but that's a long-winded way of saying there's 3 of those digits here, right? Because if pink, purple, blue, and dark blue are a family of digits, if you want to call them that, then tan, orange, green, and yellow are the other one. So if 3 unique digits of the 4 are seen here, then this one can't be It can't be the other digit. You know, there's only one more digit that has a relation together in that segment of digits. Those dependencies. So this is blue. This is light blue, dark blue. That's the only thing that's left. And what that means is all of these digits are the remaining of these. These three digits come from this world of digits. And the second that happens, these ones now have to come from what's left. Well, and it is true. Well, actually, it's done. This puzzle's interesting, but I can tell you what these are now. Because we have to put, we can see here, we need a light blue digit in here. Light blue, so we need a light blue somewhere down here. And then we have purple and pink. And purple and pink then have to be somewhere down here. So all three of these are spoken for. And this one's not pink. So it could still be purple. This could be purple, pink, blue. This could be blue, pink. Oh, all X's and V's are given, aren't they? That's meant to help me with this. If this is blue, then this is pink. And this is purple, and that's fine. If this is purple, this is pink, and that's blue. That's fine. Okay, that doesn't actually help yet. But where do you put dark blue in this box now? You can't put it down here. You don't put it there, and it's not 5. So this is dark blue. That gets rid of that, and that gives us a dark blue here. Okay, so what does that mean in relation to this? All X's and B's are given. So this digit here cannot be low, can it? How could it be low? Because if we just assume that our of those 4 digits, I was talking about that relation of digits earlier, let's just say it's the 1-4 pair. So 1, 4, 6, and 9 are the digits. 1 and 4 sums to 5. 1 and 9 sums to 10. 4 and 6 sums to 10. 1, 4, 6, 9. If in the middle you have 1 or 4, you need to have 2 more digits on either side of it from 1, 4, 6, or 9. Let's say it's 1. Can you put 2 digits beside it that don't intermingle? 4, 6, and 9. No, you can't. It always has 2 friends. If there's a 1 in the middle, you have to break the rule. Because you either put a 4, 6, and then 4 breaks the rule because it sums to 5, or you put 6, 9, but then 9, 1 breaks the rule. Same thing's going to happen with 4, right? If 4 is in the middle, 1, 6 or 1, 9. Yeah, this can't be a low digit. This has to be a high digit. And now what does that mean? If this is a 6, what do you have to put beside it? 9 and 1? Yeah, that's going to be fine. But there is going to be another high digit over here, isn't there? You can't have both low digits here now. Because if you have both low digits, you're instantly going to break the rule. There is a high digit here. 2 high digits, which means this is a low digit. And if this is a low digit, well, it could still... Actually, let's think about that now. This is a low digit. So if this is a low digit, this is a high digit that doesn't sum to 10, and then these digits repeat. Or if this is this is a low digit. If this is a high digit, then it's fine. It's fine. Okay. So what is this? Ooh, this is tricky now. This digit here, let's think about this. This is a low digit. Ooh, let's think about this. Well, if this is a low digit, this is already a high digit. It has to be. Because if this is a low digit, this can't be a low digit because they'll sum to 5. So this is a high digit. And now I think that means, well, let's just think what that does. If this is 1 and this is 6, doesn't matter. It's just the opposite one. Okay, we might start lettering, but I want to keep thinking about this. This is 6, 7, 8, 9. Well, actually, this is not 6, 7, 8, 9 anymore. This is only 6 or 8 because it has to have a relationship that lets it sum to, or that lets it half. So 6 halves to 3 or 4. Now, this is a low digit. I don't know what it is yet. But the fact that it's low means that this could go either way. So let's take our blue digits quickly and let's pencil in 6, or let's just take off 7 and 9. 6 and 8. Well, 6 and 8 have the relation, and this is not necessary yet, but 6 and 8 sum to 10 with 2 and 4, so they're not 1 and 3. And then these ones would be 1 and 3. That's the corollary of it, right? These are not 2 and 4. They're just 1 or 3. And then their friend is just 7 or 9. Okay. Not that that helps me yet, but I can start to think about it. Okay, where do we put a pink digit in this box? Right, because it's not there, but that's it. Okay, never mind. What are you? You are of this same school. So a blue digit has to be somewhere up here, dark blue, that is. And then what else do we need? 1, 2, 3, 4. Yeah, so that's all. Yeah. Again, what have we learned about that though? This digit. Well, it could be low because this could be blue and this, yeah, okay. Can't tell you anything about that yet. Um, but what I can tell you is there's always an orange up here because there's an orange down here. Orange is always up here, which means orange is not up there anymore. And the second orange is not up there, what does that say? It's either a 5 pair that's yellow, green, or it's yellow tan and it's a 10 pair. If it's yellow and tan as a 10 pair, then what digits go here? You'd have green, orange, and blue. And you'd have to have, well, that's okay. Yeah, that's all fine. What 3 digits do we need down here then? Because this will help eliminate something up here. We need a 5, which I'll color with brown. Oh yeah, 5's always brown. 5, yellow. Oh, yellow and green. Yeah, that's true. So yellow and green aren't up here. So tan is not here. So this is a 5 pair. Okay. Well, all right. So what's in the middle here then? We need orange and tan, and we need dark blue, I suppose. I suppose that is the case. And then I can tell you that this is not dark blue because that would violate this. There's no green dot here. So can this be? Yes, it can. Okay. What can I tell you now? What's the next piece of the puzzle? Um, what's this pair? Well, it's not a 5 pair that would require what? Um, it's not a 5 pair at all. It's a 10 pair, isn't it? If it's a 5 pair, what could it be? It can't be blue and pink because of this pink. It can't be green yellow because of this green yellow. So it's a 10 pair. And it's a 10 pair that's not blue, dark blue, because one of them's here. It's not the pink purple 10 pair. So this is a 10 pair of this nature. Okay. Um, yeah, that's true. And we're gonna start lettering, I think. Maybe, maybe not. Let me think. Maybe just we can just keep coloring for now because we can ask ourselves a couple of things. You know, we certainly need a green and an orange in this box. And I can tell you that neither of them are here. So they are on opposite sides. They can't be beside each other. If the green's here, the orange is here. And maybe we can think, because we can see how that works here with yellow and pink, or pink and purple, except we're lucky enough to have them colored in the sense that, you know, this one of these will be pink. One of these will be purple. And then what? We just need orange and green. But I don't know who goes where yet. Yeah, I don't know who goes where yet. So let's just keep thinking. Well, all four of these digits are spoken for. And two of them are here. So two more will be here. So it's not so we need dark blue, pink, purple. What does that mean? This digit here, can this ever be pink? No. If this is pink, you can't put purple in here, and you have to put purple in here somewhere. This is pink, this or this couldn't be purple. This central digit is not pink. So now what does that mean? If this is blue and this is a 10 pair, then this is purple and this is pink. Does not work, actually, does it? Because there's no dot here. If this is a blue digit, the puzzle's broken. If this is blue, this is purple, this is pink. It can't be blue because there's no green dot here to indicate that this is allowed to be a purple pink 10 pair. So let me think about it. So if this is blue, this is purple, this is pink, it's broken. This is pink. And now, because this is pink, this cannot be purple. It's not allowed. Because that would be a 10 pair that we're not allowed to have. So this is not purple. So this is purple. And then this is not pink. This is pink. Okay. So we need a blue digit somewhere up here. And we can't have a 5, actually. So this is another high digit. I don't know which one, but it is in fact a high digit. This is not brown. I just saw this can't be 5. Oh, okay. Well, that solves that then, because this is 5 now, isn't it? This is 5. It has to be, because if this is yellow and green, this is yellow and green. There's no dot here. This is not possible. That's 5. This is not 5. So back to numbers. This is 5, which makes it 5 there. This is nothing. This digit here is brown. This is pencil mark nothing. Is that all 5? 1, 2, 3, 4, 5. Yeah, that's all the 5s. Okay. We always have a purple digit up here, because our old friend Sudoku tells us. We always have a pink digit somewhere down here, not in the middle. Sudoku says so. So one of these is always pink. Now, what does that tell us about these relations? Well, it tells us that if this is, and you know what, the way to think about this now, actually, we don't even have to get this far ahead of ourselves. The way to think about this is none of these can be light blue. These can't be light blue. There's a light blue somewhere over here. And what that means is this is not light blue. This is dark blue. This is therefore light blue. Also, it couldn't be light blue because there's no dot here that would break the puzzle. Yeah, I could have seen that, couldn't I? Have 1, 2, 3, 4. This is going to be one of those digits, and its only options are green or orange, because those ones are spoken for. Yeah, that's true. Okay. So back to the math here, or the thought process. How do either of these not become a 5 pair? If this is pink, this is purple, not possible. Purple has to be up there. If this is pink, this is purple, not possible. Purple has to be up there. So whichever one of these is pink, it has a light blue digit beside it. Yeah. Oh, but this is not. Look at that. That's beautiful. This can't be blue because it's beside pink. There's no dot here to say I'm allowed to do that. So this can't be blue. So this can't be pink. So these are solved as is, which will put a blue digit somewhere up here. Oh, that's just nice. That's just nice. Oh, this isn't blue anymore. That's been available. So this is blue because, you know, we can see that it's spoken for. This is blue. Okay. Wow, this puzzle's excellent. NurglesGift, you've done really, really well at this. Oh man, this is really, really nice. So these now just have to be, let's just color them in that they are green and orange. And see if that spikes anything. And of course there's no problem with that yet. Okay, so this is a low digit now. Always a low digit. So this is only green or yellow. And that means this is tan or orange. So we have a we have a green yellow pair. We have a tan orange pair. So this is the remaining of the colors blue, no, purple, pink, and it can't be light blue. And better yet, this can't be blue either. So this is blue. So this is, in fact, pink or purple. No, it can't be pink. There's a pink here. Is this just purple now? 1, 2, 3. And this, yeah. Yes. 1, 2, 3, 4 pairs. Yes, that's true. This is not purple. This is not light blue. This is now forced to be pink. This is not blue because of this blue. Then this is blue. All right, neither of these are purple. So it's a different high digit now. So our options for high digits are orange or tan. And that's going to be the only options here. Okay, what can I now tell you about the relation of all of these things? Well, let's color in the last digit here. This is of this school of 4 colors. We need one more low digit here. I'll color all those things. Well, it's just the 4, isn't it? Because blue's always up here. It's just these 4. Okay, now what do we know? Let us revert to letters at this point, I think. I think we're just going to have to. Because what we can say, and maybe where do I want to start? Maybe I want to start with this. This digit here, we're going to call A. And no, I'm not. That's not helpful, actually. That's not going to help. What will help is this. I call this A. So I call this B. So this is both B's that sum to 10. So these are the B's that sum to 10. There's a low and a high digit here that are of B that sums to 10. So where is the A low digit? It's only here. This can't be a low digit. So this is a high digit. Or sorry, this is a low digit, and it is the low digit A. This is the high digit A. So this is A. And I will take off the numbers. It's not necessary for that. For the point I'm trying to make, the exercise I want to get done. So now we're going to need a B middle digit. So the B high digit is up here somewhere. So this is a B blue combo. This is an A, or yeah. So what does that, what does that mean? Well, what it means is let's examine this box. And we get a digit. Almost. We get that A, okay, so let's make sure our logic's correct. This is A, and this is B, and A and B sum to 5. Well, if A and B sum to 5, and we need to sum to 10 here, and we can't use A, we need to use B. B sums to 10 with some other digit. What that means is A, the low digit in our A pair, has to be here. And so the high digit A has to be here. If the high digit A has to be here, it has to have the low digit A beside it. And that then forces the low digit A to be in the middle here. And the second that the low digit A is in the middle, A is yellow. Yeah, so those are not green anymore. So this one and this one are not. So this one is not that. So this is not that. A is now yellow and tan, so B is these colors. So this is tan. So this is not tan. So this is brown. Yeah, we're going to get rid of the letters. We don't need it. That was helpful enough. Orange is left from this now. Yellow's left. This is green and tan, and that doesn't break any rules. This is not yellow anymore. There is always a yellow on this. How is it this? It's yellow, green, orange, or it's yellow, green, orange, yellow, green, orange, or yellow, tan, green. That's fine. Okay, sure. Carrying on. This is an A. So this is a B. Wait a minute. 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 Oh yeah, no. That's fine. That's fine. That's fine. That's fine. But this now, green is always here. Yes. And that makes sense because we know A has to go with 10. So this is not orange. This is green. Green is, oh crap. Okay, wait. Was that a mistake? I think that A was a mistake, but I'm just gonna keep going on here for a second and see what I unwind and if I've broken anything. That A shouldn't be there. Where it was, it doesn't make sense for it to be there. Yeah, it doesn't make sense for it to be there. So, okay, this is not yellow. So yellow's always here or here. Okay. 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 This is not tan because of this tan. This is not tan. Oh, so this is orange. So this is tan. So this is green. So neither of these are green, nor are they tan. So this is not yellow. So this is not orange. Of course, it couldn't be anyways. This is not yellow. So this is yellow. This is now not yellow. So this is still fine to be a 10 pair. Oh, this is not yellow. Oh, so this is a yellow digit. That's fine now. Yeah, that's fine. Oh, and then yellow, this can't be 10 because that would be a 10 pair that we're not allowed to have. Oh, we're so close. Okay, so where do we go from here? Let's get rid of the lettering. Don't need it yet. Might revisit it with different letters to clear up the last of this. But what I do know is all of our yellows are only 3 and 4. So we can take off 1, 2. And that means for green digits, wherever they reside, green is only 1 or 2. And that means orange, wherever it lives, is 8 or 9. And that means 10 is not 8 or 9. 10 is only 6 or 7. So where is this not allowed? Somewhere it's going to not be allowed, right? Surely somewhere it won't be allowed. Yes. Well, better. Blue now has to be 6 or 8, and orange has to be 8 or 9, and they have to be consecutive. So blue is 8, orange is 9, which makes blue 2, pink 3, purple 7, green 1, yellow 4, blue 8, and tan is 6. So where do I go from here, and why can't I figure this out yet? And let's go back to letters. A and B. So this is B, and this is A, and this is A, and this is B. And so what that lets us do is say, well, you know what it lets us do? This is a naked single, isn't it? This is just that. Yeah, I didn't need all that other fancy stuff yet. That's just that. So this is 6. And then I'm gonna ask you, where do we go from here? And that I just have to quickly figure out. Our options for our high digits. These are 8s and 9s. And then these are 6s and 1s. And that's fine, isn't it? This one can't be 1 because it's beside a 9, and there's not a dot allowing it to be a 1 here. So this has to be 6. So A is 6. A is 6, and 6 is the color tan. So these digits are not tan, therefore they are green. And if they are green, they are 1. And then this one, because of that, it cannot be a 9. So it cannot be rust. So this is rust. And then this is therefore blue, and this is therefore rust. Blues are 8s, and rusts are 9s. Wow. 3-star coloring puzzle. 46 minutes, 40 seconds. 98 people have solved this in 12.3 hours. NurglesGift. Beautiful puzzle. I really didn't know if I was going to be able to get that. Excellent logic. Thoroughly enjoyed it. Everyone, please try that puzzle. And if you enjoyed the video, please consider liking and subscribing. I had an absolute blast on that one. And thanks, everyone, and we'll see you on the next one.